Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm here with Ziyad Hanna from Cadence. We're going to talk today about the automation of design with AI. Ziyad, AI has been around in EDA for years, right? I mean, what's changing?
Well, yeah, indeed. Ed has been around for many years and being leveraged in the core algorithms of EDA tools, for the whole spectrum from design, verification, physical design, and so on and so forth. And it's fully deployed. Now, with the recent development of Gen AI and agentic AI, we see that AI can create content, can do much more complex tasks empowered by language models. And we see the whole industries worldwide, not only chip design, trying to get leverage of these advancements. And this put us in a situation that we can take this in advancements in language models and agentic AI to make a significant leap in our way of designing chips and how we verify them, how we make the physical design implementation of them.
Most of this has been done at the leading edge so far, though, right? I mean, you think about 2 nanometer chips, you really do need some help to get those done. But when you get into analog chips, when you get into some of the older nodes, that's not necessarily the case. A lot of people are pretty comfortable doing this. How will it affect them?
Well, if you think about any task that being done in the chip design, regardless of the digital verification, custom design, analog design, etc. These are complex tasks. They're driven by engineers, by experts, and they are fixed tasks. I mean, flows being created manually with the scripts and recipes. So we need to optimize these flows by leveraging data cross platforms, cross kind of domains, and AI comes to into play here to be able to make these flows much more, advanced and more intelligent to squeeze more results. So I keep saying that people live in silos in the chip design. You have experts in timing, experts in coverage, experts in place and route, but the data is not being leveraged enough with AI and agentic AI. The data will be leveraged and we get much more crossing among these data in different stages in the flows. And I believe analog design, like in circuit migration, layout migration, or in the chip design, physical implementation like place and route, or in the front end design and coverage information, conversions of properties in formal verification. Lots of these complex tasks will be much more optimized and much more smarter leveraging the AI and agentic AI technologies.
So AI covers a lot of different steps here. How does this actually play into the design cycle?
Yes, indeed. Basically, AI is, many people talk about AI in the industry. We try to put a framework to organize the concepts and the ideas and how the evolution of AI in the, in chip design industry. And I want to impact, the different, users around the globe. So let me show you a slide about what we mean by this framework.
What are we looking at here?
Actually, we see here kind of different categories of applications of AI along the different domains in the chip design, including design, creation, digital design, custom packaging system, etc. And for each category, we have a level of involvement of AI to do and make some automation in that area. So we have level one, which is the optimization AI, meaning that we have leverage of data to improve the core algorithms of our tools in all these areas. Improvements happens mostly through reinforcement learning and core machine learning technologies to improve these algorithms. This has been around for many years. Have Cerebrus in the digital design implementation, Verisium in the front end and validation space, custom, including Virtuoso Studio and Allegro and Optimality, etc. So we cover all the design tools basically with optimization AI, and it's been around for many years. For example, Cerebrus has more than 1,000 tape outs already using optimization AI. Verisium with Sim AI for optimizing the coverage and bug hunting and basically improve the holy grail loop for finding, to improve the coverage and finding more bugs, including these algorithms in Verisium and Verisium apps. And again, the Virtuoso Studio basically is the way to automate the layout and analog implementation with these algorithms. So this is level one. We're excited about that being around 4 years. Level two is basically where we come at the leverage of language models, and we call it conversational language model AI. Basically, it's a contextual, meaning that we introduce AI assistants in all the tools to help the engineers to ask any question, even complex questions about the design, their tools, documentations, log files, any available data in the context. And this is our basically questions, answers. This is very powerful because even experts, they don't know tools very well. They may know 30%, 40% at the maximum of the capabilities of the tools. So AI underneath, with its exposure to the whole data and whole tools capabilities, it can do much more advanced and can know much more about the design and the tool capabilities to answer questions by users. Level three, which is yet another set of questions, but this time we call it reasoning AI. In this case, AI can create content for users. For example, creating setup files for all these tools, or creating content like RTL, like schematics, like system Verilog assertions in the verification space, and all this kind of content, which usually takes many hours and days for even experts to create them. So with reasoning AI level three, we think that this will be a very powerful tool for assist the user in creating these contents. Level four basically will go even much more complex. So while level two and level three improves the productivity for the individual who runs the tool and the specific task, level four becomes much more involved. Basically, it can assume responsibility on entire workflow. Imagine, for example, if you want to have RTL sign-off. Basically, it requires lots of kind of tooling and checks for DFT, for low power, for lint, superlint, CDC, RDC, multi-cycle path, and many of these complex checks around the RTL. So this is a long and very sophisticated flow that requires many people to develop and maintain and run it regularly every day. So with agentic workflow at level four, we automate this. We give the AI the responsibility to plan, to execute, and reflect on the results to improve the workflows. And actually, these agentic workflows can create much more advanced and more sophisticated flows that can yield much better results than human being and even experts. So here we see the great saving here when applying the agentic workflows, especially in the chip design. Many flows take any team, any chip design team in the world. They have kind of tens, even maybe hundreds of different flows being created and maintained by human. And the agentic workflow comes here to make sure that these workflows are much more productive and can yield better results. So at Cadence, we create the Silicon Agent, which is a set of agents and agentic workflows to automate different and various of these workflows in the digital design implementation, verification, custom, and packaging, and so on. And actually, this is a hierarchy of agents that work together and collaborate with each other to achieve this automation. And we believe with the Silicon Agent, we can get full automation going forward. Of course, it's a journey, it takes some time, but the foundations and the way we create these agents and put them together will achieve lots of automation and improvements in any metrics of functionalities, coverage, correctness, PPA in the physical design implementation, and other metrics of security, etc.
Where are most companies today on this level one through level five? So level five, I assume, is push button. You know exactly what you're going to do, and this has been talked about for years, and we're still a long way away from that. But Where do you see most companies actually playing it, and what's the struggle to get from one to the next level?
We are working with the whole industry, for regions, every regions, and see that tier one, the big ones, the big customers, they invest internally in developing their own infrastructure because they have experts in AI and the chip design, and they have their own data. They want to leverage that, so they build some capabilities around AI, but still using, in the EDA industry for groundings for the tools to collaborate with AI. So most of them around level two, I can say. Some of them started to look into level three for creating some content. Maybe the advanced customers, they start to invest in building infrastructure for agentic workflows, but it varies. I believe the majority of the customers still at level two, basically trying to leverage the foundation of language models for basic stuff, basic questions, answers, summarization of documents, searching in documents, building external memory for the language model like RAGs, leveraging their documents and their access to the language models. Initially, in let's say a year back, many companies in the chip design they said that well they don't want to access internet because this can expose their IPs, their data outside, and they want to do everything local. But I see a shift these days that companies they see that if they use only the local language models or the open source, so they first of all they need to invest in building the infrastructure with the GPUs and maintenance and enable that capacity locally. A, B, these open source language models are way behind the cutting edge. So to be able to make big progress, they need to kind of leverage these advanced and recent language models from the main providers. So we see them are more open for private cloud services and kind of branch out from their local on-prem data and tooling into the cloud, but still secure cloud areas there.
Each one of these levels is a new level of abstraction. As you add abstractions, you also introduce the potential for things going wrong and people not understanding what's going on underneath, right? So if you go to level three and level four, you're pretty far distant from how this actually plugs into the design.
Exactly. I agree with you. This is one of the big challenge in AI. AI at the end is, the Gen AI at the end is a statistical model that gives the context and predict the tokens or the outcome from that AI session. They are actually very important to do what we call the grounding. Grounding means that how to supply the AI with facts, either from the design knowledge from the designers, from the data that exists, related to the task, or from the local network, or from tools that provide to give this grounding to enable that the results to be much more accurate and correct. At the end, we live in the exact science in chip design. So it's not statistical models need to play and dominate. We need to have much more in groundings and guidance of the language models. That's A. B, and assume that the agentic workflow works and start to create results. We need to have this traceability to be able to understand what decision being taken by AI and why they taken and how to debug that and how to improve this, how to have the human in the loop to improve the decisions and the flow that language models took during the agentic workflow. So yeah, we're going from left. We have everything deterministic with agentic, with optimization AI into agentic workflows. So we start to see much more flexibility and power given to the language models. And imagine these workflows can run in parallel. We can run, 20, 30, maybe 100 of these workflows in parallel. So how we're going to interact and who will control this interaction? So these are big, big challenges ahead of us. And I believe customers they think that they can build their agentic workflows independently. I believe they can do the simple ones. Advanced ones that requires lots of deep knowledge in groundings and tools and data and hardcore software engineering. This is the EDA industry will take care of it.
In order to do that effectively, you really need some deep knowledge on the side of the engineering team too, right? They really need to understand all the way down to the metal. What's happening there? What can possibly go wrong? Are we getting the right results here? Are we doing something wrong in terms of setting up the AI infrastructure?
Indeed, this is what I say, that traceability, to be able to know what decision being taken by AI and why this decision was taken. And if I want to change that decision, how going to impact that? What are the knobs and let's say the callbacks or API that this agentic workflow provide controllability to the user to control and understand what's going on. It's part of the challenges here. There are two, when you go with basic or simple agentic workflow, you give the whole control to language model to do these basic steps and make the decision by itself. But in chip design, that control need to be engineered in the sense that this workflow, like think about it like a multi-steps workflow and agent that can collaborate among each other and have the control being communicated among each agents. And the users should have the control and the knowledge what's happening here to be able to debug and can bypass all these steps by manual things or by reusing some data that being prepared before. And maybe that the user want to stitch, one step can be replaced with other steps that the user want to do by itself. Working with this agentic workflow will be our next challenge in the whole industry here.
So what happens when we get into things like chiplets? We're no longer dealing with just a monolithic design or even a package that is the traditional way of doing it. We're now looking at very, very unique elements that you're going to put into the context of whatever your domain is, whatever your workload is.
I think that decision about the chiplets is still, will continue based on the complexity of the workloads, etc. So I believe AI can help in, planning the chiplets and the partitioning of the system, but it's not going to do all things together in, one chunk. I believe the main contribution of AI in the next few years in the IP design and verification, which is still by itself a very complex task to achieve and get to autonomous situation there. So there are attempts that we are trying with our customers even to do assembly, to know how to get from different IPs, from IP catalog, and build a full chip RTL and verification collateral out of that using AI. It's doable, but I believe it's going to be a modular design, and AI will help in creating modules and help in the assembly. But I think with the chiplets and the overall design and floor planning and partitioning, still the architects and the key architects will be working to do that decisions there. AI can assist in that as AI assistant can do some experimental work to achieve some of the numbers to help in the decisions. But I don't think that the entire thing will happen right away. It will take some time. Maybe at some point in the future we can rely on AI as well to build all the chip, including the chiplets as well.
Ziyad Hanna, thanks for a great explanation.
Thank you. Thank you very much.